अस्सलाम वालेकुम स्टूडेंट्स। आज का आपका टॉपिक चैप्टर 9 फिज़िकल ऑप्टिक्स में से यंग्स डबल स्लिट्स एक्सपेरिमेंट का है, जिसको सबसे पहले यंग ने परफॉर्म किया था। और ये बेसिकली बेस करता है इंटरफेरेंस ऑफ द लाइट वेव्स पर, और ये हमें हेल्प करता है इन ऑर्डर टू अंडरस्टैंड द वेव थ्योरी ऑफ लाइट. So before going towards the Young's double slits experiment, first you have to understand what is interference of light. You have studied about the interference of the sound waves in the previous chapter. Here the same thing is experienced, but it will be practiced with the interference of light waves. So interference of light waves is actually the superposition of two waves with the same frequency and direction, and as a result of that superposition, the resultant amplitudes of the waves is either increased or decreased depending upon the conditions. यानी इंटरफेरेंस में दो वेव्स जो हैं लाइट की वो आपस में सुपरपोज होती हैं, जिसके रिज़ल्ट में जो एम्पलीट्यूड बनता है वो या इंक्रीज़ होता है और या डिक्रीज़ होता है, डिपेंड करता है कि वो किन कंडीशंस में आपस में मिली हैं. सो हियर आई हैव मेंशन्ड द बेसिक नेसेसरी कंडीशंस for the interference of the light waves. These are the basic condition. The first condition is the two waves must be coherent and monochromatic. They must travel in the same direction. They must be at the same place and same time. Additionally, if the two waves are in phase and they have the path difference, d is the path difference. If they have the path difference either 0 or 1 wavelength or 2 wavelength, it means the integral multiple of the wavelength, then the resultant interference pattern will be the constructive one. But if the path difference between the two waves is half integral multiple of the wavelength, the resultant interference will be destructive interference. Look, the mathematical formula for the constructive interference is represented as d is equal to m lambda, and for the constructive interference, and for destructive interference the formula is represented as d is equal to m plus half lambda. This is the diagrammatic representation of the constructive interference, and this is the diagrammatic representation of the destructive interference. This is the experimental setup for the Young's double slit experiment. Here we are placing a monochromatic light source which is incident initially on a single slit in order to make the beam as focused or concentrated. We are going to make it rectilinear, and after that the light waves are incident on two slits. Here in this diagram, try to understand the different parameters. Look, there is a slit 1 which is represented by A, another slit that is represented by B. So these are the two slits. That's why the experiment is known as double slit experiment. The midpoint between the two slits is represented as E, and the total distance, the spacing between the two slits is represented as D. Here is the screen upon which we will be observing the interference pattern, either in the form of constructive interference or in the form of destructive interference. Don't forget that you have studied the interference of the sound waves. So as a result of constructive interference of the sound waves, loud sound was produced, and as a result of destructive interference, low sound waves were produced. As here we are talking about the light rays, so the constructive interference for light waves will be represented by a bright spot, and the destructive interference of the light waves will be represented as dark spot. So the whole experimental arrangement, as you are looking here in this diagram, is kept very symmetric, such as the interference pattern over here upon the screen will be symmetric as well. By symmetric, I mean we will have some regular pattern, like if the midpoint at the screen is a bright point, means if it is representing the constructive interference, then the next spot will be dark, then bright, then dark, and so on. We will be obtaining the alternate bright and dark spots above the mean position as well as below the mean position. Instead of considering the whole interference pattern, we will just consider some of the points in order to make some calculations. So look here, I consider just a single ray coming out from slit A. This is ray 1 that is coming out from slit A, and it is incident on the screen, suppose at point P. Similarly, another ray 2 is coming out from slit B, and it is incident on the same point P. I suppose that these two rays are constructively interfering with each other at point P, such as point P is considered as a bright spot. If the two rays are destructively interfering at P, then P point can be considered as a dark point. Here I consider the P point as bright, means ray 1 and ray 2, when reaching at point P, they are interfering constructively. So if you can see that ray 2 travels some distance larger as compared to ray 1, so we will be determining that extra distance covered by ray 2. So if I do determine the extra distance covered by ray 2, so this is BQ, which is represented as S. So S is the difference of the lengths of the two rays, ray 1 and ray 2. So this is basically BQ, or S is basically the path difference between ray 1 and ray 2. Now we know that if this path difference is integral multiple of the wavelength, then P point will be a bright spot, constructive interference, and if this path difference is the half integral multiple of the wavelength, then P point will be a dark point. One another point you have to notice, the distance between the slits and the screen is represented by L. So this is the whole experimental setup of Young's double slits experiment. I hope you have got all the parameters and the whole construction of the experiment. This is what I have mentioned, all those parameters which I told you from that diagram. You can repeat it from here again. Now, I consider the small part of that diagram, which is composed of the slits A, slit B, the path difference S, and the distance between the two slits, that is D. So from this smaller triangle A, B, Q, I will be confirming the conditions of the interference. So now look, if I do calculate sine theta for this smaller triangle, so sine theta is equal to perpendicular by hypotenuse. Perpendicular here is BQ and hypotenuse here is D. So I got sine theta equal to BQ divided by D. Since I have mentioned that BQ is the path difference, so if I do write BQ, so that is equal to D sine theta. So BQ can be replaced as path difference, that is D sine theta. So here, look, path difference comes out to be D sine theta. Now, according to condition of constructive interference, if this D sine theta is m lambda, then we will get the bright spots, bright points, which will represent the constructive interference. And if this path difference is m plus half lambda, then the spot or the point will be the dark point, and that will be representing the destructive interference. So this is the very first result from the Young's double slits experiment, which is confirming the conditions of the interference either in the form of construction or in the form of destruction. Now the second result is we have to calculate the distance of the spots. By spots I mean the distance of the dark spot and the bright spot from the central position. Look here at the diagram. This is the central position O at the screen. P point, which I considered initially as a bright spot, I can consider this P point as the dark as well. So in order to calculate the distance of the bright spot P from the central position O, I will consider the larger triangle EOP. You can traverse the larger triangle EOP. So for this larger triangle, if I do calculate tangent theta, that is equal to perpendicular by base. Perpendicular I am going to represent by y and base is represented by L. So tangent theta will be equal to y by L. If I consider the theta is very small, then tangent theta is equal to sine theta. So I can write it sine theta equal to y by L. So remember, this is equation 1. We will be utilizing it in the next steps. So now look, if we consider the P point as bright spot, then it does mean that it was following the condition of the constructive interference, that is d sine theta is equal to m lambda. As sine theta was y by L according to equation 1, so if I put d y by L instead of sine theta, I will get dy by L equal to m lambda and y is equal to m lambda L by d. Similarly, if the P point is considered as dark, then the condition will be modified as d sine theta equal to m plus half lambda. So if I put equation 1 here, the value of the sine theta as y by L, then the condition will be modified as dy by L equal to m plus half lambda and y comes out to be m plus half lambda L divided by D. So this is the distance of the bright spot from the central position, and this is the distance of the dark spot from the central position. This was the second result. The third result from the Young's double slit experiment is the distance between the two adjacent spots, either the bright one or the dark one. So first we have to calculate the two bright spots. So for that, let's assume that the central spot was bright, for which the distance was calculated as m lambda L by D, such as the next bright spot will be 1 times increased from the first one. So I will write the next bright spot as y m plus 1 equal to m plus 1 lambda L by D. Now, as we intend to calculate the distance between the two adjacent bright spots, so I will be taking the difference of these two equations. So the difference of these two equations will provide me with the distance between the two bright spots. So the distance between the two bright spots I am representing as delta y, and that comes out to be y m plus 1 minus y m. So by putting these two values over here, I will get the result as delta y equal to lambda L by D. The next is the distance between two the next is the distance between two dark spots, for which I consider the central spot as the dark one. So that is y m is equal to m plus half lambda. If it is a dark, so it will follow the condition of the destructive interference, which is m plus half lambda, such as the next dark spot will be represented as m plus 1 is the higher, the next one to the first dark one, and it will be following the condition as m plus half plus 1 lambda, such as again we will be calculating the difference of these two equations, so which comes out to be delta y is equal to lambda L divided by D. Look, the result for two bright spots and two dark spots are very similar, means two bright spots and two dark spots are at the same distance from the central position, because we have considered the symmetric uniform interference pattern at the screen. Now the last result is, if there is one bright and one dark spot, so what will be the distance between one bright and one dark spot? So for this purpose, suppose the central spot is the bright one, such as it will follow the condition of the constructive interference, and let's suppose that the next spot is the dark one, and that is m plus half lambda, that will be following the condition of the destructive interference. Now again, by calculating the difference of these two equations, we will be subtracting them, such as a result we will get the distance as lambda L divided by 2D, which is actually the half of the distance between two bright spots and two dark spots. So these are three results we have calculated from the Young's double slit experiment. The first result is the confirmation of the constructive and destructive interference. The second result is the distance of the bright or dark spots from the central position, and the third result is the distance between two bright, two dark, one bright and one dark spot. So we have calculated all these results. I hope Young's double slit experiment is clear to you people. Okay, thank you.